Hey, hey, stranger in the night right at the beginning. How lucky is this? What's up, cool cat? Oh, glitch cat. Glitch cat. Nice. Yeah, so this is day 19 of 100 Days of Code. You already had it up and waiting? Nice. Nice. Yeah, day 19. And let's see, yesterday, and the day before actually, we just played a bunch of coding game. Today I'm going to move back into data structures and go over graphs. Already have some stuff pulled up. Most of the other data structures, except for tries, I had at least looked at or played with at some point. But starting at tries and the graphs, I don't have any idea what's going on, so this will be fun. Yep. So that's what's happening. Apparently with graphs, there's an adjacency matrix, an adjacency list, an incidence matrix, and an incidence list. But this article only goes over the two that are adjacency. And I'm gonna try and implement them. And I think it takes this style looking graph. So a graph would be each of these nodes is a data point. So 0 is the data, 1's the data. And then they're connected basically by the lines. I think they're called edges or something like that, but they're connected by the lines. And so unlike a linked list where one is just connected to the next one, or a binary tree where one is connected to two, one item can be connected to as many more as there are in the graph. Oh yeah, here's like use cases for them. Cool. Graphs are used to represent networks. Networks may include paths in a city, or a telephone network, or circuit network. All right. Graphs are also used in social networks. For example, in Facebook, each person is represented with a node, so like the 0. Oh, with a vertex, so that's the graph terminology. Terminology is key. It's a vertex. And that'll contain all that person stuff. Oh, cool. They have a link to applications. Maybe we'll look at that later. Oh, that's the Wikipedia article. Yeah, I know where to find that. Okay. Cool. Hey, Jim, what's going on? Nice to see you. Thanks for the follow, by the way. Welcome to my coding life, if you will. There's lots of reading. And then later on, there will be code. Oh, you're just painting? Nice, nice. What are you painting tonight? Okay. So there's an edge from vertex to vertex. All right. You'll just be listening? Yeah. Got the music, and you can always hear my lovely voice. Got some orc archers, nice, going on. Nice. Stranger. So is this memory or databases or related to both? Not directly related to. Man, that's hard to say. Yes, it's related to both. Memory, in such that this will take up memory once it's implemented, and moving through the graph will take up memory. So RAM, random access memory, specifically. And then there are databases built on this principle of graphs. So using that Facebook example, Facebook stores all your information and then connects you to everyone that you're connected to, and so on and so forth with every other person that's there. Does that help? That's what I was thinking. Cool. Then you were spot on. Okay, so in this case, this is a two-dimensional array, so an array that holds more arrays, and each of those arrays' indexes will represent a node. Okay. Even if the graph is sparse. Oh yeah, it still takes up the same amount of space. Whoa. I didn't even know they had one of these. So from to... The arrays are managed by the server memory. Yep, that's right. Or if it's like if this code were passed to the front end to your browser for some reason, it would be managed by your computer's memory. All right, I think I'm just gonna do the adjacency list. So the adjacency list stores an array of lists, which is confusing. But basically, the first array, the top level one, holds all the node values. The arrays are managed by server memory, and that would be SQL stuff. SQL stuff? Not quite. So SQL is server query language, and that gets run on the database itself, which is on a server. So I don't... Yeah, maybe that's getting out of my depth. How would the data be stored? In a database, it could be stored in like a database table. And the thing that sets up this graph data structure is how all of that data in the tables are connected. So if you had a table of users, and each user had a row of data that was like name, address, so on and so forth, and then connected to that user is a table of friends, And so user 1 has 200 friends. That friends table would be the implementation of this graph data structure. All right, the C++ is simple. Well, short, succinct, I'll say. Maybe not simple. Add edge. Okay, so they're passing the vector, the length of the vector, or the amount. Not sure what the capital V is. 0 and 1. Then it prints it. And C, it's quite a bit longer. Huh. All right. Let's try and translate the C++ version. Oh, I don't have any of the stuff set up. Facebook must have some insane code. Yep, I completely agree. The amount of data and traffic that they have to deal with is crazy. And they're on such a scale that they have to worry about data over distance as well. So the latency in the cable makes a big difference. Graph. Oh, no, it's array. I want to make a new file. And this is a JSON. I'm going to have to look at how to spell that. ADJCY. Okay. JSON C list.rb. Not a coder, but you try to think like one. I don't know. You're getting pretty good at the thinking like one from what I can tell. You might be a coder before you know it. Okay. And I can copy over some of this test boilerplate. This would be graph slash. You've become a better question asker. Yeah, that's definitely true. The terminology is starting to fill in for you. Let's see. You keep it simple. Some of them are. Mountacross, what's going on? How are you? Thanks for joining in. Today I'm taking a break on Code and Game, and I am learning about graphs. And currently I'm setting up code to try and implement an adjacency list, which I've never done, so we'll see how this goes. Okay. So the boilerplate is there. Don't know if I need to. I'll probably put that driver code in. The tests. Is there like a syllabus that you follow for 100 Days of Code thing? There's not one that you have to follow. You can kind of set it up as much as you want, or however you want. The official 100 Days of Code challenge is the only rules are code for an hour each day and tweet about it with hashtag 100 Days of Code. Past that, you can kind of do what you want. My first focus is data structures and algorithms, and I found this cool. Well, this is kind of the article that inspired it all. Is on Geeks for Geeks. I found this 100 Days of Code guide, and they give you some framework as a syllabus to go through stuff. But what I was most interested in is this data structures and algorithms. And they give you like a cool list of stuff to go through. And like setup for today, I literally just clicked on graphs, started reading about them. If I can get this adjacency list figured out, I'll go into breadth first search. Yeah. So I'm loosely following a curriculum, but I'm kind of picking and choosing. And for stuff that I'm not familiar with at all, I literally copy the code from Geeks for Geeks and then translate it to Ruby, because they don't have Ruby. So I tried it the first couple of times and it was way easier to understand what was going on after I got some code working. So this takes the vector. Not sure what pushback is. So def initialize. I could probably just make an array and then push more arrays to that. Angered Gecko, welcome. How are you? Glad you're here. We're currently working on implementing an adjacency list representation of a graph, which I've never done before. Yeah, doing pretty good. Excited. And hopeful that I can get this working, I think is the best way to put it. And a little nervous about implementing breadth first search on this. I know we need to add an edge. I'll probably take, since I initialized the array, I'll just take a source and a destination. Yeah, I don't know what good names are for those. That makes sense. So for the position in the top level array, you push the value of the other vertex that it's linked to. Okay. dot push. Oh. No, it's already there. It's already there. Dang. Okay, so that's straightforward enough. Yep. Have to remember to do my Ruby variables. My Ruby naming structure. Snake case. Okay. This is going to go in the test. So I don't need this here. I want to do at list equals adjacency list dot new. And at list dot add edge 0, 1, 0, 4. Oof, 1, 2. Okay. And I'll make a test. I'll just print out and see what this looks like. So print at list. All right, I don't need this open. I don't need this open. Make an attribute accessor for array. I could probably come up with a better name for that. Cool. Now I should just be able to run the test. Graph adjacency list. Perfect. Define local variable method. Oh, did I misspell something? Adjacency list 8. Yeah, makes sense. Okay. That's fixed. And define method for push for no class, which makes sense. Oh, I wonder, how are they handling this? They're already passing in the adjacency array. Cool, so they're setting a vector that already has those in it. There's a nice trick for that if you wanted to switch to storing the adjacencies in a hash. trick could be. So it'd be in a hash, right? And then I don't know what you would do here. Because would it be a hash of arrays? Oh. Huh. Okay. So does that mean like pushing to this, it will just push to it? I would assume there's already an empty array. I would assume there's already an empty array under that key. You have to go to the default value part. Yeah, okay. Yeah, because I think even with the array, I was going to do something like that. And same for destination. And I don't know if that's, I don't think that's the trick you're talking about though. Oh, right, of course it's nil because I changed the name of it. Okay, let's make sure that lines up with my test stuff. Okay, so 0 gets a 1 and a 4. 1 gets a 0 and a 2. 4 gets a 0. And 2 gets a 1. Yeah, that's right. Okay. Oh, so basically it's hash.new. What? Oh, that looks crazy. Oh, can I copy that? Okay, I can't. That's fine. That's fine. It's not. I can type it out. I am going to try that. Oh, it's hash.new. Hash.new. Oh, I see. HK. equals an empty array. Okay, so you're instantiating a new hash and you're passing a block to that new method, and I'm guessing this is hash and key. Yeah, I'm gonna look that up. This is moving into the Ruby foo realm of things that I am not quite there yet. I think I'm on 2.5.7 right now. Exactly. Okay, cool. Hash key. What? By key that doesn't correspond to a... What? This is crazy. Aldecross, thank you for that. That's awesome. Huh. And just so I remember this tomorrow, I am going to call these hash and key. Hash and key. Cool. All right. So let's see if it... And it works. Oh, that's so awesome. Cool. Yeah. Thank you very much. Oh right, I've got to print it out. Okay. Yep, added, super easy. And then, yeah, we'll just print it out for now. And then I'll probably change it to something that I can test. Oh, there's some weird things going on there. That's fine. Utility function to print the adjacency list representation of a graph. So it takes in the hash. I guess that is the maximum number. Let's go look at that. My fallback is to look at the Python 3 code. V. So they're initializing with the number of vertices. Huh. Self.v. Range I and self.v. Oh, maybe it's not printing it out in the way that I thought it was. I think it's just printing out each one. While temp.next. Huh. Okay. So I don't need any of this. I can just do something like at hash dot each to key value, and it won't print it out in order, but we'll at least see what's there. Yep. Equals. Oh, they're actually setting next. Add edge. Node.next. What? In 0 to value dot length -1. Oh, right. Ski. What's value I? That list print graph. Huh. That's not great. All right, let me try and envision how this is actually printed out. Adjacency lists of vertex. Ah, okay. See. So they're literally mapping down the array and printing out the adjacency list for each one. That I could do. And hash out each, and then after that, I want to puts the string. And that should look a little bit better. Yeah, nice. 0, 1, 4, 2. I wonder if I can print them out in order. I don't know if order matters, so I'm not going to worry about it too much. Cool. Yep. That seems to work just fine. Okay. Thanks, Mount Across. I appreciate that. Thank you once again. Is refactoring I can apply? Well, yeah, I definitely want to. Let me see. Okay, so it's probably in here. Oh, I bet there's something you can do with the array, isn't it? Let me think. Value dot. People generally frown upon 4 in Ruby. Oh, that's good to know. Ruby arrays are super powerful. Okay. Yeah, I haven't been working with Ruby for too long, and yeah, definitely this is my first time working with Ruby in public. So any best practices or like Rubyist type things, I am super down to learn. All right, so 4 is round on. See you, Jim. Thanks for stopping by. Yep. All right, so I bet it's something like Ruby concat strings in an array. So let's say, okay. That makes sense. And then it's a one-liner instead of. Yeah, so that's what I thought you were talking about, is the value.join. You're a Ruby master. This is awesome. And then this can start to look more like this. Oh, yeah, I see. But that's an easy fix. I can just put it there. Huh. Wow. That's way more succinct. Huh. Super cool. That's way better than what I was doing. All right. Breadth first search. Okay, that makes sense. Graph, add edge, yep. Okay, so they're making another adjacency list. They're keeping up with the number of vertices. There's that add edge function. But they're only adding it one way this time for some reason. Oh, I guess that assumes it's not everything is a two-way link. Yeah, this is what I need. Zero, 1, 2 to 0. Yeah. Okay. Yep, so it's easy enough to modify. Def search. Don't need this. Though I am gonna set up and use the same edges that they are. That way I can test my code against it. Search for add edge and replace it with. Nope, don't want to do that. Okay. Test. Breadth first reversal. Okay. Assert equal. Then I'll make this an array. Cool. Oh, no. Is that what I want? That's what I want. Cool. And now test will fail. Perfect. And I've got a nice little adjacency list that I can reference. Okay. C++. Let's grab this graph. That's so wordy. Was it taking an int? Oh, that's the thing to search for. Yep, okay. Right? No. Alright, I'll figure out what that S is later. New bool V. What is that even doing? Mark all vertices as not visited. Oh, it's yep. Thank you. The C pointer to the array of bools. Is it painful to watch me struggle? Not really? Okay, good. Okay, and then I'll print out visited just to make sure that's doing what I think it is. Oh. Cool. Saved. This is one of the rare occasions I see someone doing testing voluntarily. Oh, yeah, it's a great practice. And I super value testing now. I went from working at a consultancy that didn't do a lot of testing to working for a product company that has thousands of tests, and the time that all those tests have saved is, yeah, I mean, yeah, I just don't even know how to explain it. It's unbelievable. So I am a big proponent of tests, to say the least. Yeah. That's false. Great. That does what I think it does, so that's good. All right. I'm just going to use an array for the queue. And only say shift and push. Mark the current node as visited and then queue it. Let's see. That's where the num comes from. bet when they call this, they're passing in 0. No? Following was the breadth first traversal starting from vertex 2. Oh, okay, so you can pick the vertex. True. Q dot push vertex. Oh, we used to get all adjacent vertices of vertex. Okay, so here's the nut of it, if you will. I equals 0. I'm gonna try and implement the while loop to start with, and then I'll refactor as needed. While q dot empty and let me scroll up a bit. Okay, DQ and print. Makes sense. Oh, that's interesting. Huh. Is it shift? I think it's shift. I'll just call it temp for now. Print it out. That's where I'll push it to the testable array. Okay, then I need to get all the adjacent vertices of the DQ'd vertex. Adjacent has not been visited. Top again. And so it looks like this is mapping over the adjacency list for this vertex. And if it's not visited, it pushes it to the queue, or it enqueues it. Terminology, stranger. Oh, and since I have a hash, that makes grabbing the adjacency list a little bit easier. Hash temp. There he is. He's still here. Perfect. Dot each. Oh, okay. Vertex. I don't think scoping affects that here. You know what? I'm not sure. So I'll just call it I. And I can q.push I unless visited I, right? Yep, think that makes sense. All right, so this takes a vertex, and that is 2, and now I can test it. Broken, super broken. I missed something, obviously. Right. I don't know how to one line. Yeah, that's okay. I don't have to do that. I missed the part where I marked them as visited. Okay. Hopefully that will keep me out of an infinite loop. 2031. Yes, that's what I wanted. This is just so I can test it. And then I want to dot push temp. Okay. I have to return it. I do have to return it. Let's put that where it's supposed to be. Return the array. Still failed. Did I not put it in the right spot? Oh, I did not. Yes, got it to pass. That's awesome. Okay, cool. So, removing all of this. It's all geeks for geeks. If I really need to go back and get it. Okay, so for breadth first search of a graph, we pass in a vertex that we want to start at. I guess there is no like root or head for a graph. That might not be true for all implementations, but for here, I assume that seems to be the case. And then we create a visited array and set all of those visited things to false. Oh, I bet there's something I can do to initialize that array. Then we created another array. It's a queue. That way we can push the vertexes to the queue. So that's cool. Oh, and we set the vertex that we started with to visited. Okay. And I never use this, right? They have an iterator here. Yeah, but I just never used it because I figured out a different way to do that while loop. Okay, so up to this point, everything's pretty straightforward. When we get to the while loop, we keep looping until the queue is empty, which is really similar to breadth first search for trees or binary trees. And then we shift the front of the queue, or DQ, and print it, or push it to the answer array. And then we map over, because we're storing the graph as an adjacency list, we can map over that adjacency list. And if, I always have to read unless as if not. Yeah, so if it's not visited, then we set it to being visited and push it to the queue. And then we loop over it again. And we push off the, yeah, that's awesome. Okay, and that's pretty straightforward. At least having implemented breadth first search for a binary tree first. The thing that always gets me about these data structures is how to visualize them in my head. But this helps tremendously. Seeing the adjacency list actually printed out. Okay, man, that's farther than I thought I was gonna get in about an hour. Yes. Yeah, so let me see if I can do something like this. What I'm thinking. Ruby create array with values. What? Oh, the monkey patch approach. Okay, I don't really want to do that. Ah. That's exactly what I want. So similar to mount across your new hash. Array.new hash.size false. Boom. Okay. That's exactly what you wanted to suggest. Perfect. Perfect. That means I'm learning. You've already given me knowledge. Given me knowledge. Yeah, that's super cool. Oh, and this would totally have helped with implementing the tries. I might have to go. I'm going to go back and review all of these at some point. But this will be awesome for implementing the try. Because I was literally doing the 26 times adding nil to the array. Okay. Then queue.push vertex. That's a little silly. That kind of breaks the cube, but I could add the vertex already. I'm not gonna worry about that though. It's pretty heavily nested. I don't immediately see a better way to do this though. 10 beach.2. Yeah, seems good. Seems good. Let's make sure that array.new works. Yeah. Yeah. I love little stuff like that. Cleans it up just that little bit more. Yep, cool. I guess I'm gonna keep moving through some graph stuff. All right, depth first. Yeah, that sounds good. Sounds like a good follow-up to breadth first search. Wonder if they're gonna do it iteratively. Unlike trees, graphs may contain cycles. A node may be visited twice. Okay. Okay, cool. I've already used a visited array, so that's not out of the question. That's not new information. Using adjacency lists, okay. Ruby also allows false times at hash size. Oh, that's cool. Just for something different, I'll do that. False times at hash size. Wow, that's cool. An array of false times a number. I guess that makes sense. I was trying to think about it from a code readability standpoint. From like just straight up succinctness, thinking about like the amount of characters, right? In your code, this wins over array.new. Yeah, I guess if you know Ruby well enough, it's no difference either way. Cool. Saving that for later. Oh, I should make a commit. Yeah, let's do that. And graph JSON. Such a hard word for me to spell. List and breadth first search. Cool. Def. Sure, we're gonna pass it a num. That's what I want. Okay. The root node. Okay. Mark the node and move to the adjacent unmarked node and continue the loop until there is no unmarked adjacent node. Yep, makes sense. Then backtrack and check for other unmarked nodes and traverse them. Finally print the nodes. Yep. Create a recursive function that takes the index of node and a visited array. Mark it and print it. Oh, hey, thank you for telling me. Number of vertices. Search util. Oh, okay. Visited true, printed out. Search. Mark them all as not visited. Okay, and then just call the depth first search util. Makes sense. Mark the current node is visited and print it. Okay, makes sense. Mark it as visited, print it out. And then for each node in the adjacency list, if it's not visited, mark it as visited and print it out. And they're passing that visited every time. Oh, recursion breaks my brain sometimes, but I think that makes sense. I'm going to see if I can do it without referencing this code. Or without copying it, I'll say. I'll still reference it. Okay, so I know I'm going to want an answer array. And then visited equals array.new at hash.size false. No Q because it's recursive. Recur equals. Let's see if I can get this syntax right. Lambda. Nope. And then for each one, I want to, right, this will be index. I want to mark visited at the index to true. And then array.push index. Oh, no. Hash index dot each to Hey, Anger Gecko, what's up? Oh, I forgot to ask you what brings you here. Surfing through random science and technology channels. Nice. Yeah, graphs are cool. Graphs are cool. I'm having fun with it. Definitely having done some binary tree stuff is helping with this. Do you code at all? Are you a programmer? Nice, nice. What type of stuff do you do? Ooh, competitive programming. So is that like C, C++, short, fast, and tight type programmings? People usually use C++, but sometimes Python and Java. Python, really? That one surprises me. Java, I'm not too surprised over, because it's fast once it compiles, right? And I guess Python is fast. I guess I don't know too much about competitive programming. It's about reading problems quickly, figuring out algorithms, data structures to solve the question, implementing and submitting. Yeah, not too useful in real life. It's basically a sport. Yeah, it looks super cool though. I've definitely, I haven't watched any of it live, but I've watched some YouTube videos on it of people doing it, and it looks stressful. It causes me stress just watching them do it. Can't say you're too great. Hey, you're doing it though. You're doing it. So that's a step in the direction of greatness. Then I need to return the array. For your breadth first search is visited just a regular array. Yep, it's just a regular array. Maldacross has been sharing with me these like cool new Ruby, or new to me, Ruby array and hash initializers. Yeah, basically they take stuff. So this creates a new array of a size with a default value. Won't it break if you have any non-contiguous keys or non-integers? Keys. Yes. So the implementation here is making a lot of assumptions on the inputs that I'm getting. So it's assuming integer keys in order 0, 1, 2, 3, 4, no breaks. Oh, I'd started using an array of lists, but Maldacross suggested. Yeah, I would have just used an array of arrays. It's all the same, I think. Maldacross suggested using this hash instantiation that takes this block of hash and key, and then for each key in a hash, it initializes a default value. So then I can just push straight to that value without having to do a check. That's the reason I'm using a hash. Yep. Yeah. Idiomatic is the word that Maldacross used. It'd be faster. Oh yeah, because I guess access time is still really fast because you already know the index. Maybe when I review this tomorrow, I'll try it with arrays and see how different that is. Still increases constant by a good chunk. Gotcha. C++. Fiskar, what's going on? Nice to see you back. Yeah. Vector is better, safer, faster choice. Huh. Yeah, these are good thoughts. I like this. Oh, I have to figure out how to test this. Or I already have a test, but okay. Should probably include the equals. Oh, yeah, of course it worked. I have to actually say depth first search. Usually you use a set of vertices for visited in Ruby. Do the same thing for Python. Oh, okay, nice. Before I forget that, use a set. Only optimize the vectors if you need speed. Depth first search. Okay, so that should actually call it now, and that test should fail. It's not returning anything. This is because of the recursion, isn't it? Yeah. Oh, no, I'm not calling the recursion. Dot call num. Okay, cool. I think I know how to fix that. Nope. Failing. Let's just print them out and see what happens. It's only printing 2, so it's not recurring at all. so there is stuff. There are vertices. Okay, 0 and 3. Silly. Okay, let's revert back to there. Gotta hop off. Good luck. Thanks, Anchor Gecko. Thanks for stopping by. It was awesome. Thanks for all the good conversation and hints and tips. All right. Looks like we've got something. Is that right? Let me see if I can think through this. So we start at 2. So it is 2 to 0. And then 0 to 1. And then 1 to 2. And then back up. Yeah, it's got to go to 3. Okay, so that looks right. Goes back to 2 and goes to 3. Cool. Okay. And then just for good measure, I'll make another one. It's also starting at 2, so that should be fine. Fail. Define method add edge. Ah, yep. That'll do it. TFS. Cool. Okay. Yep, so I understand the visited array. You don't want to do anything on it if it's been visited. Am I wrong, or is it possible to turn breadth first search into depth first search by changing the data structure into a stack? I don't know if you can just drop in Drop it out. Oh, it should work? Ooh, okay. Yeah, I've never tried this. I don't know if it's just drop in, drop out. Okay. That's fair, Vizgar. So you'd want to push. And then here, you would want to pop. It will at least do something. So if it's depth first search, I've already got the appropriate tests in place. Ah. 2301. Okay, so that's not quite right. What is it doing? It's going to skipping over 0 and going to 3. Two, 3, then 3 goes to 3, and then back to 0, and then 0 goes to 1. Is that post order? So for my actual algo, no, just drop in, drop out doesn't work, or drop in a stack doesn't work. Funny. Oh, because it's still pushing temp. Just listening, so I wasn't certain. Oh, cool. Yeah, though I do want to figure out depth first iterative for graph. So that's perfect. And we'll see if they have... Are you curious? You're going to go implement it? Awesome. If you get it to where it's drop in and drop out for stack and queue, share like a gist or something, or I guess replet's probably easier. You don't have to, but it'd be cool if you did. Iterative depth first search. Let's see how similar it is. Yep, stack of nodes, visited array, insert the root into stack, run a loop till the stack is not empty. For every adjacent and unvisited node of the current. For every adjacent and unvisited node of the current node, mark the node and insert it into the stack. Draw it on paper and think about what first in, first out versus last in, first out does. Yeah, that's a good suggestion. I can do that. So you're marking visited nodes. You're basically, yep, that sounds right. That's how I've been thinking about it anyway. So we have 0. We start with 2, so that's marked off. Sorry, that's pushed to the stack. Then 0 gets pushed to the stack, and we go to 2. And that's already been visited, so we go back to 0 and go to 1. That gets marked as visited. And then from 1, we go to 3 and push it under the stack. And then it pops off as 3, 1, 0, 2. Yep. Okay. My crude drawing of... Oh, you can't even see it. Yeah, lighting's not conducive to pencil on paper. Yeah, I basically drew this out and then mapped it out as it's stepping through the iterations. Yeah, so if we start at 2, it basically just ignores... Yeah, it ignores the self-link there. It ignores this 1 to 2, it ignores this 0 to 2. Because we start at 2, go to 0. Then we go down 0's path. 2's already marked, so go back to 0, go down 1. 1 to 2, 2's already marked. Then we go to 3. And those get all pushed to the stack in that order. So then we pop off the stacks. 3, 1, 0, 2. Oh, that's not what it was. 3, 1, 0, 2. Yeah. 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 Okay. Set the current source node. Oh, push it. Alright, so we start at the root, create the visited array, create the stack, we push the source node, so the stack's not empty, the while loop if it initiates, we pop the top of the stack, which is currently the source node, and it's not visited, rinse it out, marks it as visited. And then for each in the adjacency list, if it's not visited, push it onto the stack. And then it pops the top again. Oh, so maybe I thought about that wrong. Pops the top, prints it, and then goes to 0. Does the same thing. So it's really similar. Oh, hold on a second. Ah. Now let's run the test. Oh. Well. I thought that was going to do it, but it didn't. What am I missing here? Stack may contain some vertexes twice. So we need to print it only if it's not visited. Got it. Temp. Unless visited temp. Haha! Fail. Okay. I got excited when I saw the green dots. So where are they getting set to visited? Oh, if it's not visited, print it out and set it to true. Cool. Infinite loop. That's not good. What's this? Hype brain. Thanks, stranger. I appreciate you. Alright. What I'm really doing is copy coding. I need to actually stop and think about this. Thanks, stranger. Okay. Stack. 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 Infinite loop. It's not good. Queue is never empty. Stack is never empty. If it's not visited, push it. Oh, am I literally just printing this in a different order? Let me match the test data. Make sure we start at the same spot. Starting at 0. Okay, cool. So that means that do you actually need to call the iterative one? Wait a second. Let me do this one. Cool. So it is 0, 1, 0, 2, 2, 2. Oh, these are literally the same things. No need to do those twice. Now I'm super confused. Oh, it was just cleaning up this visited temp equals true. Ha, nice. Okay, let's see how close this is to... Can I... Yeah, Let's get some room in here. It's easy to see it. Oh, I don't like that. There we go. Cool. Okay, so I got it to work, and they're not terribly different. Right. Yep, you don't set visited true in the beginning. You still push to the stacker queue while the stacker queue is not empty, while loops the same. You push in the same spot, but you check if it's visited first before you push it. And then you set visited to true in that same check. And the reasoning was because you can have more than one representation of a vertex in that stack, which could probably be cleaned up. I'm not sure. Yeah, and you remove the visited true here. So they're really close. Oh, did I mess up a test? I must have messed up a test. Yep. Okay, cool. That feels more like home. So this is correct, I guess. Does that mean it was working from the very beginning? Goodness. Now I have to know. Oh, nope, not there. So, mounted across in Visgar. After 40 minutes to an hour of me monkeying around with this and moving stuff around and making it look closer to this code, you guys were right. It just prints it out in a different order. So, Visgar, yes, your hint for FIFO, LIFO was on point. And and I do not understand. I do not have a good enough understanding of that, apparently, which is a good thing to learn. So thank you. Huh. Draw a deeper tree on the paper, not a graph. Yeah. Okay, that's fair. Okay. So we... You learned this stuff on Code and Game while trying to get rid of recursion. Nice, nice. Yeah, recursion is kind of mind-blowing trying to think about the order in which things get recurred upon. Because things are definitely happening in an order and not all at once. But the way the code reads, it makes me think it's happening all at once. Okay, so while the queue's not empty, pop from the queue. And push it to the array. It's loading, it's loading. Okay, that looks familiar. Adjacency. Oh, huh. That's cool. Is it the shovel operator? I don't use that ever. I don't know much about it. Breadth first search. Too cute next. Oh, this is cool. Next. I don't know what this is. Yeah. This is super cool. Is this big enough for you guys to see it? I can zoom in a bit. Maybe I can't zoom in. There we go. Yeah, that's super cool. Yeah. So the traverse is agnostic, like you say. Specify it from the actual implementation. Q traversal. Q.shift. Oh, huh. And keyword.call. Depth first search. Traverse F2. What is this in Qer? Next. Call. Q adjacent. What? That's cool. syntax. Okay, there's several things I don't understand here. Yep, the set's fine. Q equals F. Oh, you're passing in. Okay. Yeah, this asterisk and this enqueuer. I guess enqueuer is what you are. It's just a way to pass in a method to another method. Traverse F, depth first search. 2. Yeah, the and the asterisk. Enqueuer.call. Huh. This is good. I've got some things to look up on this here. Enqueuer is the block that's passed between do end. Oh. Okay, that makes sense. Gotcha. Okay, the and syntax is how you signify that this accepts a block, right? So something like lambda in other languages. Maldacross, that's for you to answer, I think. I don't know enough. It seems more like a callback function. That's how I'm rationalizing it anyway. Oh, that's not quite right either. Because you're passing in the queue. Oh, nice. Yeah, I should do that. Huh. Yep, so it creates the same graph. Yep, using that data. Nice. Looks familiar. Starts in the same spot. If you're trying to implement something like beam search, then you simply change from first in, first out to last in, first out to some kind of ordered list. It's filtering unnecessary items. I'll take your word for it. When I get there, I'll remember this. Huh. So the call takes in the queue and adjacent dot current. So that's a new hash. So that takes in the adjacency array. What is this? Asterisk args. Is that like the spread operator? Yep, variable number of arguments. Oh, that's super cool. So you're just pushing in the whole array or unshifting the whole array. Huh. Okay, that's awesome. I'll save that for later. Yeah, that's it. Okay, cool. Took me a while to get there and understand it, but this is good. You're showing me what can be done with Ruby. Huh. Okay. I'll fall on over that later. Alright. Awesome. Oh, I can get rid of all that white space for sure. Cursive and iterative. Just stream your New Year's resolution. Kind of. The idea was there well before New Year's, but January 1st seemed like a good day to start it. That way my 100 days of code can line up with at least January for day number wise. Yeah, now that I think about it, maybe the better answer to your question is yes, but it is my New Year's resolution, but it's been in the planning for a little bit before that. And by planning, I mean convincing myself to actually do this. Cool. Read me. Yep. Day 19. Lots of stuff. Graphs. What did I do? Element. Yeah. I remember what it's called now. JSON. Let's see, list. for surge. Surge. And recursive. And depth first, iterative. Looks right. Depth first. No. I don't think I'm even going to link it. Instead of Q. Yep, cool. Okay, that's good enough. All right, so I've updated the README. That means this stream is about to come to a close. Get status. Yep. On REPL, there's my C implementation of getting a graph spanning tree. I tried to write it. Nice. Nice. What is a graph spanning tree? So many new things. Graph spanning tree. You forgot already? Nice. A spanning tree has all the vertices covered with a minimum possible number of edges. Does not have cycles and cannot be disconnected. That's probably super high level, but it at least gives me an idea. Gives us an idea. Why would anyone? I don't know that. Okay, commit. And day. I did get the day right this time. Trying to finish your degree. Nice. Yep, that'll do it. To the README. Push. Sweet. All right. There's a few of us left in here. None of my friends are on to raid. Do you guys want to raid somebody? Or if you have someone that you would like to raid, let me know. Perfect. Strangers in. Let's see. What was the question? Sorry. So I'm about to end the stream, and I was curious if there was anyone that you guys wanted to raid. That's it. Okay. Cool. Yep. Have a good one. Thank you so much, Mount Across. I appreciate it. And have a great rest of your day. All right. Let's just pick somebody. Sweet. See ya. How do you spell it? Strager. Thanks. Thanks, stranger. I appreciate that. All right. With the couple of us that are here, gonna raid this guy named Strager. Seems pretty cool. If anything, it'd just be Stranger and I. Make sure I got his name right. Yep. Once again, thanks everybody for being here. This was awesome. I really appreciate it. And I'll see you later. Let's raid Strager.